Thanks everyone for coming today. Hope your morning's been going well. Yeah, today's topic, as I mentioned in the email last week, is we're going to revisit. I wanted to revisit Git and kind of talk about sort of the practical using Git practically, whether that's like workflows, like in use cases where Git might be helpful, and then when you're using Git, how do you use it when you're collaborating with other people? Because that's really what Git's all about, right? It's about like working in a team, committing code, and then putting it all together in some one repository. So I thought I'd give an overview of that, like sort of different Git workflows. There's merge versus rebase, like two different options for combining your commits into like a main branch. And then maybe if we have time, I have like the tiniest, most bare like demo repo that I created, maybe in the last hour, maybe not. So I thought maybe we could dive into if we get to that. Yeah, I guess just to get people's sense of knowledge, you can either raise your hand with your video or in the team's like raise hand function. Who's like worked on a Git repo in a team, like with other people before? Okay, nice. So a good like half of us. Awesome. Yeah, so if you have, so there's sort of like, at least from what you'll see, if you looked at the Atlassian tutorial I sent, and the way I've kind of been thinking about it, it seems to be a couple different like approaches to using Git collaboratively, depending on the size of your team, right? On the one level, maybe using Git by yourself, and you just have your one main branch that you're committing to, and then you push it remotely and to GitHub or GitLab, and that remote repository serves as sort of like your remote. That's where like you're storing like an official version of your code or a backup version if it's just something you're working on. You don't really need a Git workflow for that because it's just you, right? You're just like kind of backing up your code. But what if you're working with one or two other people and you're in a small team? How do you make sure that, what I'm working on, for example, isn't affecting what someone else on the team is working on, so that when we both push to main, we don't get conflicts, which are a whole other thing that are in Git that are sort of scary and messy on the surface. They're not the end of the world. I used to get really nervous whenever I used to like try to rebase or merge and get like that conflict warning. I would freak out. They're not the end of the world, but you do want to avoid them because they're just an extra bit of work you have to deal with. So how do you do that? Well, I'm going to share my screen to that article because I like the figures they had, and then we'll talk about exactly how you can do that. So what is a branch in the first place? Well, a branch is kind of like, if you think of the tree model of Git, right? Your main repository is sort of the trunk of that tree. And then a branch is obviously like a branch from that tree, like a deviation from whatever the main stable threaded repository is. And you can branch sort of like at any point in your repo. And basically, you make a branch, you check out to that branch, you do some work. Usually branches are created for different features, or maybe if you're in your team, each person might get a different branch to do whatever they're working on. But it's basically a copy, I guess, I don't know, a branch is sort of the best way to describe it. You're branching off of the main repository. So you have all of the commits that are on the trunk, and then now it's just like a single alley of the repository for you to commit to. And then when it's ready to merge back into the main trunk of the tree, you can do that. Yeah, and so there are two main ways of merging a branch back into, or combining a branch back into the trunk of the your repo or the main branch. Sometimes they call it main or master or development. Most of the time I hear main, so I'll stick with main. And that is, so those two main commands to combine your branch back into main are git merge and git rebase. And the main difference between with merge, you're basically creating a new commit, like the action of combining the branch with the main trunk is itself a commit. So you're going to have like a merge commit, and that's fine. That's one way to do it. The other way to do it, which we on the research computational team like to use, just because it's a little bit cleaner in terms of your history of commits, is git rebase. And what that does is, say you have like, your main branch. I guess if we're looking, I'll use what's on the screen. Say you have whatever, your feature branch here in this green, and you want to add it back into main. What rebase actually does is basically you can think of it as like slicing off this branch and grafting it on top of whatever the head or whatever the latest commit of main is. So you are like literally rebasing that branch, and putting it on top of main. And that way it's sort of preferable, at least for our team, because then we have like a nice clean Git history where it sort of looks like it was like, if you sort of look at our Git history of main, it'll look like people were just pushing and pushing to main or committing to main. It's like one march of commits, even though what really happened was there were a bunch of branches and they were just sort of rebased on top of main and put back in there. Whereas if you had merge, you'd see all these merge commits in there, and that would indicate like, oh, you could say, oh, there was a branch at one point there. And you may or may not still have that branch. We tend to delete our branches after we make them. So that's why it sort of makes more sense, I think, to use rebase, because our branches are a little bit more loosely defined. Like if you were in a really tightly controlled development environment where like, a branch is for a very defined feature or very defined, like, there's a very defined function that you were working on. Then maybe it might be worthwhile to like keep that branch in your history for, but at least in my experience on our team, like our branches are not as coherent in terms of like a theme or like what exactly you're working on. It's more of just like, oh, this is my branch. Whatever I'm doing, whether it's related task or not, it's all on my branch. And then we just rebase it onto main and to make it look like one clean march. So those are sort of the two options for combining your branches back into main. And sort of like the trade-offs between them, or why you might use one or the other. And I do kind of want to show some of those commands, especially rebase, because that's what I use and that's what I feel like is pretty powerful. But before we do that, I wanted to pause and ask, like, does anybody else have like any thoughts they want to share in terms of using merge or rebase, what they've done in the past and what's worked for them, or why they've chosen to go with one or the other? Yeah, Bennett.
So once a branch is merged, so I just want to clarify first off, once a branch gets merged, you can delete the branch and there are no side effects other than the branch history is gone. The main reason that branches are done, well, so there are a couple of reasons for branches being done. The first is if you have a bunch of distributed developers, then the branch is where all of the work that is needed in order to make something usable happens, and discussions about it can take place in the branches themselves. So that if two people are working on something in a branch, they can discuss it, make changes, commit to the branch, and then when it's then deemed appropriate for it to go back into everybody else's view of the world, that's the point at which the branch then gets merged. And then there's a way to either leave behind all of that discussion that was in the branch or bring it along with you, which either of which is appropriate depending on what you want your histories to look like. I think that branches are probably more important when you're working on things that are on a web-based Git repository system, because it's often the case there that there's a third party who is the release manager. And so that third party will approve whether your merge request or your pull request will actually happen into the main branch or not. So, so it sounds like most of the work that you guys are doing has got a really compact view of who's working on it, what the extent of the work being done is, and what the review process is before it goes back into everybody else's view of it. Was that any help at all?
Yeah, I wanted to spend it like when you, because I haven't used merge hardly at all. So I'm glad you brought up that clarification. Like when you merge a branch back into main, I know you have the merge commit, but say you do delete that branch you just merged. That all that branch history, all the discussion that took place on that branch goes away, right? And it's
It
just
depends
all you
on
have left is
whether.
that merge.
So when you do your merge, you can do the merge where you, Shelley, help me out here. What's it called? Trimming the,
I was blanking too on it. Hold on.
it's collapse.
Yeah, I know what you mean.
Squash.
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 Yes.
Yeah,
Okay.
squash.
So if you squash your commits, what it will do is it will give you an opportunity to take all of the commit log messages that occurred in the branch and edit them so that there's a summary of the changes that would be important for people to see once it's in the main branch. That way, if you had, as Shelley and I can both attest, many back and forths about merges for things like typographical errors and little file moving and renaming stuff and all of that, we can make that go away, but we could keep the discussions about why are we using this method, which algorithm is actually being preferred, etc. So that's a way to clean up the messiness of several drafts that are occurring off in the branch, so that what you end up with then is sort of, here's our branch, here's the executive summary of what it did, and then that becomes part of the main branch's record. Did that help clarify?
When you say summary, do you mean like that's not an extra commit though?
It is a commit.
Right. Oh, it is a commit.
All we're
Yeah,
talking
so-
about here is what the log says.
Okay.
What
So when
gets
you-
committed remains the same.
I think the difference is what the squashing is, it shows as one commit instead of like,
Yes.
8
Right.
commits.
Right, a bunch.
Versus if you just do the merge without the squashing, I think you see the 8 commits.
You get the merge
so
history
the-
from the branch.
The other difference is if you care to document who did which part of like those 7 commits. If you squash them, I think you lose that and you only have the last person who does the merging shows as the commit.
As the committer, right?
As a committer, yes.
Yeah, but you have the opportunity in the commit message to say who did what.
Yeah, you could do that.
So if we're looking at, say, this diagram of a merge, so when this person merged the feature branch into the main branch, they must have used git squash, because here we see there's only that whole branch is condensed into one merge commit.
But you'd have to look at the log to see what the merge history or what the commit history looks like after the merge. So there's basically what we're talking about here is the differences in how things appear when you do git log.
Yeah, I'm not sure that the diagrams capture like what that, like by that
Right.
one blue dot at the commit point. I don't think that indicates that it's showing, just one message versus three.
Okay.
I think the
so
log is.
so this is something that it would probably be worth finding a really verbose tutorial that
Mhm.
shows here's a thing, we create a branch, here's a commit to the branch, here's another commit to the branch, here's another commit to the branch. Then we merge the branch into main, and then we look at the git log to see what it actually says.
I see.
And
But
then
if you
things
did
are
want to,
different and get much more complicated as soon as you bring something like GitLab or GitHub in, or Bitbucket, which is Atlassian's product, into it, because they have their own histories and their own logging that are outside of the Git logging.
so you basically have two sources of logs to look at.
Yeah.
For instance, your GitHub log. Right. Yeah. You have your GitHub log, which includes things like pull requests and all the documentation that goes with that. And then you have whatever the
Right.
actual Git log.
So,
Okay. Well, that's a good distinction to make between like squash and basically that squash option to squash it into
but yeah,
one commit.
merge and read, as I understand it, when you rebase, what you're doing is so you're in a branch that has diverged from main. And then you've
Yeah.
made some commits. And then when you want to rebase, what you do is it finds the commit that was the main from which your branch started. And then it takes each of the commits that you made in your branch and applies them to main so that you can get the effect of merging main into
Right.
your branch.
Right. Exactly.
But
Yeah.
that doesn't rebase it into main unless you tell it that the source is your branch and it should rebase main to your branch instead of the other way
Right.
around.
Well, you can, yeah, exactly. So that's why I want to get into the commands as well, because you could rebase main onto your feature branch, but most of the time what you actually want to do is rebase your feature back onto main. So you can get turned around with that.
And recovering from things when you rebase is different than if you are trying to recover from a merge. And Scott's got important messages for us.
Yeah, sure.
I don't know if it's important, but it's kind of an order of operation. The rebase lets you handle any possible merge conflicts sort of in the privacy of your own branch. But if you wait to do a push to the main with your content or a merge to the main, you're kind of messing with main at that point. So doing the rebase, as you said, the rebase says I'm going to catch up my branch to everything that's happened in main since I was last over there.
Right.
So it lets you kind of do that in your little sandbox, which generally we find less risky than trying to
basically
push it to the main and decide that you're tinkering with the main flow up there at that point.
Right. You can basically ensure that you're not going to have any conflicts when you try to put your feature back into main. Because even if somebody had made changes to main while you've been checked out on your feature branch, and so now the main that you branched off of is not the main that is currently there anymore. Scott and Bennett are right. Like, yeah, you can rebase those changes from main onto your feature branch. So now your feature branch is all caught up with those new main changes. And now when you put your feature branch back into main, you shouldn't have any conflicts.
I don't want to get ahead of you. Are you going to do pull requests and such a little bit later, or?
I'm going to do some rebasing locally, but I'm not going to do a pull request.
So maybe just a quick.
Patrick's
what we have been doing in our team is is keeping the branch, doing the rebase, keeping the branch, pushing the updated branch to main, and then telling our team lead, hey, Pat, you're smart. Figure out how to get all my stuff over to main. So we do a pull request, at which point it's sort of an inspection of all the changes that are being proposed, and those pull requests sometimes go over easily, and sometimes there's some negotiation about what we're going to do. But that's kind of then the end game for these changes. That's it for me.
Patrick.
Yeah, so my comment feeds off exactly what Scott was talking about. So, whether you merge or rebase as you work on the feature branch, it doesn't really matter. What matters is when you want to bring it back into main and do a pull request or merge things back. And in my mind, I think the biggest difference between merge and rebase is rebase puts the onus on the branch writer to get things caught up and easily mergeable back in. Merge, however, puts the onus on that merge commit and the person bringing the code back in to now figure out how to reconcile things. And so when we do the pull requests and we were doing merging where I wasn't having folks rebase their branch, the pull request was a big deal because there was all kinds of conflicts. You had to figure out how to resolve the conflicts at that merge point. When you rebase, you're basically putting the onus on the feature writer to rebase their feature so that it will merge easily on the end of main. And then the pull request approver doesn't have to do anything. They just have to make sure the code isn't broken or doesn't have something stupid in it. There's no conflicts to deal with because they've already rebased it onto main. So in my mind, merge puts the onus of the conflicts resolution at the point of pull request and the approver usually is who it ends up being put on. Whereas the rebase puts the onus on the feature request person to first get their feature request conflict free and then ask for the pull request.
That's a great way of framing it. I like that framing. Oh,
It's,
yes,
so open source software projects that I've worked on, before you submit your branch for merge to main, you first merge main into your own branch and you resolve the conflicts before you make the pull request. The difference between the merge and the rebase ideally is going to result in exactly the same code at the end.
Yes.
And it's what the record of work looks like that really differs.
Correct.
And so that's a matter of what kind of records do you want to keep as an organizational entity or a coding project, and how do you want them to look? And it's also going to have some the size of your group and how closely or loosely it's organized is going to also probably affect what your chosen methodology is. Honestly, in looking over the Git arguments about rebase versus merge over the years, it seems to me like it's a personality choice, and that functionally there probably isn't really any difference between them. It's a matter of what the people you're working with and what you like best.
Yeah, that's a great point,
And
Bennett, is this fits into that whole workflow discussion, which is very much based on your team. And the workflow we've been discussing, talking about feature branches in your main, is a very popular, very common workflow called the feature branch workflow, where you have, it's so common, that's why we're kind of almost using it as a default, right? It's you have your main trunk, and then you have feature branches that you either merge or rebase back in. And real quick, I thought maybe it'd be cool to show on our repo what a pull request kind of looks like. So maybe I know some of you guys have seen this before, our forecast workflow repository. We use GitHub. I maybe it looks a little different on GitLab or at that Atlassian Git bucket, but like from GitHub here, you can see we have 2 branches. This little drop down indicates we're on main. There's another branch that's active. You can say main is the default. GitHub adds a little tag or manual guidance marker. Switch to this other feature branch, you can see, okay, this is a branch I've been working on. It's 2 commits ahead of main. So I'm going to click on that. So this is sort of the pull request interface with GitHub, right? It's sort of like the interactive, or it's sort of like the graphic interface for combining my branch back into main. So instead of it's able to merge, so it's checked for conflicts. So there's not going to be any conflicts, and that's because I've made sure to take. That's because this branch is ahead of main, so any changes I've done on this branch can cleanly fit on top, can go back on top of main. But if I wanted to make this a pull request, I would create the pull request. I would add a title, a bunch of information. You can see it has the 2 commits on my branch. You can add a bunch of other metadata through GitHub. I can suggest Pat to review it and make sure it's all good before it goes in there. And then I could create the pull request. But I myself, like at least in this repository, I don't have the authority to push whatever I made directly back into main, right? Like this is what Pat was talking about, where we have that safeguard where like, yeah, I do my developing, and when it's ready, I'll request Pat's eyes to look at it, make sure it's all good, and then it would go back into main. And then what I usually do is get rid of this branch, because all these commits are now going to, because we're using the rebase, are going to show up in the Git history for main. And so that's like this commit history when you see all these commits. In fact, you can see when it kind of shows these commits are offered by 2 people, that sort of means they were in a branch that I created, and then Pat approved them in a pull request. And so now they're all like in a nice linear history on GitHub. But yeah, so that's, yeah.
And to be fair, Noah, if we did merge without the squash, you could delete those branches as well, and all those
right
commits would also end up in main as well, but along with a merge commit.
Yeah. So like that merge commit would basically show you at what point did you have
like the fuse point.
Splits. Yeah, the fuse point, exactly.
Just out of curiosity, does anybody here have any desire to hear like why you would want to get into this complicated Git thing in the first place? I mean, I hate to take it sort of back to the real fundamentals of it all, but I mean, essentially, right, what we're trying to do here is to make it possible to divide work up into independent chunks that can be worked on by different sets of people. And then we can take the results of what they've worked on and consolidate them into a single working whole, spelled WH, not HOL, though it sometimes seems like the HOL rather than the WHOL. So Git has been used to write books and not just code. I know I have some friends who wrote a math book using Git, and essentially each branch was a chapter of the book. So each chapter's author was able to work on their chapter independently, do commits, get all of the capability of, oh God, I don't like those changes. How do I undo them? Right. So that's when you go back and you Git restore an earlier version of your chapter. And then when the chapter was done, they would submit their chapter to then be merged into the book repository. So that's essentially the same thing. So in a programming context, it could be that there's a particular set of features or a particular set of functions that somebody is going to be writing, and those are going to fit into a larger whole somewhere, but they can be independently tested before they get integrated into the main program. So that would be an example of where you would want to have a branch, and you might have 2 or 3 people working on whatever that chunk of functionality is, and then you would want to merge it back into the branch. In production code, bug fixes are like this. You check out the current production branch, you find the bug, you do what you think is a fix to the bug, you test the bug, you're good with it, then you request that your bug fix goes back into the main production branch. Somebody checks your work and then says that it's okay. Right? So I think that's a reasonable sort of overview of the gestalt of why you would want this.
Yeah.
Which is I mean, you just brought up what a lot of reasons why rebase exists as a thing anyway. So if there was a bug in the root code or the base code that perhaps you're relying on, perhaps you're not, if that bug fix gets back into the main branch, when you do your rebase, you can get that bug fix in your side branch immediately. So that you're testing the code that's been corrected, as you do your finished development. That's what the pulls can also. You can always get pull requests. It depends on whether the bug fix was in the file that you're editing or whether the bug fix was in a different file. Because Git fundamentally is a file tracking system. If 2 people touch the same file, that's when you have issues with merging and who gets what, who wins on that line of code. Your edit or my edit.
Right.
Separate files merge much easier. Which brings you into another whole conversation about how much code should be on one file and how much should you split it up? Should 2 people be sharing the same file? It's a lot easier if you're not, as far as merges go. These are all just sort of hard-won lessons over many years of working on teams of developers.
Right. I have to say, I put Git rebase versus merge. That's literally what I put into Google. And this is the first time that the AI overview actually came back with something that was useful, comprehensible, and worth reading. So that might be worth people looking at. The one thing that we found, and the reason that when we were working with a group of people that didn't always have the highest levels of communicative ability amongst the members, is that merge is safer because it's much easier to back out of a merge that went bad than it is to back out of a rebase that went bad. And if you don't delete the branches, the history of both branches is always fully available to everybody, regardless what the log in the main branch looks like. So that's all, again, that's another, right? Essentially, really what it all boils down to is these are all tools for taking disparate sets of work and combining them into a single product.
Right.
What's the style that your work group wants to maintain with respect to both the documentation and what the procedures are? And It's very different with small groups that aren't writing commercial code than it is for groups that are large and writing commercial code. All of the private companies that I worked at have had 1 or more release managers who's the ultimate authority about whether something gets included into the product or not. And they're sort of theirs is the eyes of last resort.
Right.
Patrick, it sounds like is sort of your eyes of last resort and is acting as the release manager for the products for the projects you have here, right? One of the things that at the place that I worked last is that the release manager ran every single one of the unit tests and made sure none of them failed after the proposed merge has occurred, just to make sure that there aren't regression tests. So if you have a function that's got one primary purpose, but it had a secondary purpose, often changes for the primary purpose may have an adverse effect on a secondary purpose. And so running in all of your unit tests, which is another huge topic you should probably have a talk about. Is one of the functions of the release manager is to make sure that none of the unit tests fail after changes have been made. So I'll shut up now.
Right. Well, you were getting into, I feel like you're talking about coding in a different environment, which is like maybe a continuous release environment where you have a product or a software that you have customers using. And it would be a really, really big deal if like there was a commit to main or a merge or rebase into main and that broke it, right? That would be like if you're working in a business or
Big
commercial
Falcon
environment.
spec.
Yeah, that would be pretty bad. But it reminds me of another popular Git workflow, which is, I guess, sort of dubbed Git flow, which is where you have sort of a main branch, which is like your precious, sacred, working, production code that you really don't want to break. And so if as like sort of an extra layer of protection, you have a develop branch, which is sort of where you're actively improving and testing code. So even off your development branch, you probably have feature branches, right? And then you're merging or rebasing your features onto that development branch. And then there's probably somebody else, a release manager maybe, who's responsible for merging that development branch into the precious main that you don't want to break. So it's sort of like that extra layer of security.
Yeah, you see this you see this in long running open source repos all the time. Yeah.
And so another workflow for even that I see commonly with a lot of open source projects as well is just sort of forking workflow. And forking is basically like I think this is what like big open source projects. So think like Pandas or like NumPy of those kind of things, where it's an open public repository, and you can clone it locally. But also what you do you can pull a repository, clone it locally, but instead of like pushing to that one Pandas, for example, main repository, you create a fork, which basically means you're creating a copy of the repository, your own remote copy of the repository. Actually, I feel like you could probably just go to Pandas and go to their source code right now and do that. If my internet works there. Or let me just go back to maybe they have a good forking workflow. Okay. Anyway, my internet's being funky. But basically, you can fork the repository. So now you have your own version of, I'm going to stick with Pandas. So you have your own version of Pandas on your own remote GitHub account. And then you clone that one to your local. So now you can like contribute to Pandas however you want, push it to your branch on your forked repository. And then if you want to merge the changes you've made on your fork into main, you can open a pull request to do that. But then of course you need like a release manager or somebody who's overseeing Pandas to approve that. So that's another way for those big collaborative projects to have that extra layer of security where you can have like hundreds of developers working all across the world, contributing to a project. But you don't have to worry so much about things breaking, because if you're the manager of the project or a Pandas, then you can select, okay, this person opened a pull request to their fork. I like their changes. I'll take that, or maybe I'll reject it, whatever. So it's a little bit cleaner than I'd say still having one repo of one dev branch with thousands of contributors. It avoids having sort of like, a gazillion contributors on one repo, or directly like sort of like pushing and pulling branches to one repo. Instead, you have like a fork. Any comments on those workflows? I think for most people, like a lot of the time, feature branch workflow is probably the most common one you're going to encounter, where you just have like the classic trunk branch model. Yeah, if nobody has any other comments on kind of workflows or considerations therein, I think looks like we have time to sort of jump into a demo. And for this demo, I'm only going to show Rebase because that's what I have the most experience in. It works for us. And I want to say it's taken me a long time to like really have a solid grasp of Rebase. Because it is a powerful command. But with great power comes great responsibility. So it's very easy to mess things up. But the onus of Rebase is on sort of the developer or whoever's writing the feature branch to sort of figure out, make sure that they've rebased correctly so that when you try to merge into main, there's no conflicts. And I'm going to paste this. I've used this Stack Overflow probably, like I said, 10 times to make sure I understand before I try to rebase something. But this is a little bit more of the syntax. But I think it's really helpful to sort of like go through it, and then I'll show like live coding on like a demo repo what this kind of looks like. So again, I like the grafting analogy. And I always like using this onto method because for me it just helps me, or this onto argument, because for me it helps me like make sure you can understand and like explicitly type out what I want to happen. So it just helps me write better commands when I'm doing Git. And it adds for more precision, which we'll get into, which is really nice. So you have, your main branch and then a feature branch that we're currently working on your head, right? And again, like I said, I like to think of rebasing your branches sort of as grafting onto the tree, the trunk of main, right? So say you made your branch off of this commit C, and now you've done working on stuff. But looks like another collaborator on your team has worked a little faster than you and committed, did their own branch, made some new commits that got approved and put into main. So now this main branch is ahead of your feature branch that you're working on. You can, that's a good example. Basically say you can, what I would do is rebase this onto the head. By this example, they're basically rebasing, say, okay, take this commit who's from this branch from, I guess, ignore D, but from EHI onwards, we'll put it on top of F. And so basically with the onto command, the first commit, or here they're using letters, but when you're actually typing, it would be the SHA, the commit SHA. You would say, make the first SHA you give, that's going to be the new parent of whatever branch you're working on. And then D is sort of the old parent. So you can sort of thinking as swapping parents, right? Okay, my current branch, the parent is D, but now we want to say we're going to make the parent F. And that's kind of what you get. But you can also do it with 3 arguments, which is even more powerful, where you sort of are ignoring previous commits. Say you don't care about I, say you want to just do E and H, then you can do, so we want to make F the parent, F is going to be the new parent, D was the old parent, but only go through H. So that's like, I guess for some reason you don't want to commit the entire length of your branch. You only want to commit like maybe like a midsection of the branch. But most of the time I just use these 2 arguments. I'll move my whole branch onto the main.
So Noah,
Yeah.
Your previous example, I think if you scroll up a little bit,
hmm
so the before shows A, B, C, F, G, and then the branching shows C going to D, E, and then H, I, right?
Right.
So, but after the rebase, you lost D.
You lose D. Right. I think I didn't explain that very clearly.
So does that mean that D is just a copy of what C was, and that's why it can go away and you don't lose work?
No, in this example, basically when you're specifying these SHAs, it's like, I guess you're putting onto F, but you want to take commits from this point onward, or from commits whose parent are D. So if I wanted to move this whole branch, instead of using F and D, I would use git onto F, C. Unless, oh, but I see you're asking, are C and D basically the same? When you branch, is it the same? No, I don't know. You wouldn't assume C are the same. C and D are the same. If I wanted to include D, then yeah, I would say onto F, and then instead of D, I would say C, because then I would say, okay, because this assumed, right, that I'm talking about my current branch. So it's gonna look at my current branch. It's gonna say, okay, for my current branch, we're gonna make F the new parent, and we want. If I said C, okay, we want all the commits whose parent is currently C. So that would be my entire branch, DEHI. But maybe it'd be a little clearer if I actually have an example. So I'm gonna jump into that. You can see I have a very detailed demo repo. Did have some code I wanted to add. So I have a couple files. I have 2 commits, right? I have my initial commit, and then I created a little uppercase file that does some, convert a string to uppercase.
Any chance you can make the font bigger?
Yes, thank you. Oh, maybe that's too big. Is that good?
Much better, thank you.
So it's gonna run a git status. Yes, I created a feature branch already before I whoops. Git branch V. So this git branch V command is really helpful from the command line. It shows you what branches you have created locally, what their last commit is, and which one you're currently checked out to, which one you're on. So running git branch V, you can see, okay, I'm on a branch called feature, and it's up to date with main. So basically what I just did was, well, maybe I'll show actually like how to make the branch in the first place. Why not? Okay, so now let's start from the top because I feel like that's helpful. Okay, let's say I'm just on main, right? How do you make a branch? Well, you want to be whatever branch you're currently checked out to, which in this case is main, the only branch I have, that's going to be the head of whatever new branch I make. So if I want to make a new branch, git branch, call it feature. Now run git branch v again. You can see I created that feature branch. So I officially had main, created feature. And they're still at the same point, but now I can make stuff to feature. And now feature could be ahead of main, and then I'll want to put it back on top of main. So to switch to my branch, I think newer versions of Git have git switch, but you can also use git checkout to feature. So now it says I'm on that branch feature. And let's say I wanted to make some changes to a file. So I just have some kind of random junk in here that ChatGPT made. But let's say I want to return 10 or whatever instead of 1. So, Going to Git status, you can see I modified some stuff. Gonna add it real quick. Adding, staging those changes. So now it's ready to be committed. And now you should always have a better commit message than that. It's some changes, but in any case, now you can see I made the commit. And then I want to look at my branch. Now we'll see that feature is a little bit ahead. I made a new commit. It's only on feature. I was trying to get Git Lens to work for this because it's really helpful to have that branch, but I couldn't get it to work. Or sorry, that sort of a visual diagram. Couldn't get that to work very well. I guess the kind of built-in VS Code source control has some decent visualization. So you can see that's the initial commit. That's that was also a commit that was there. This is our new commit. And if we switch to, maybe I can see everything. Yeah, okay, that's a little better. So you can see this is where main's at, and then we have features ahead of it. So now how do we want to get rebase feature back onto main? Well, usually at this point, I would open a pull request, but I'm just going to do it locally because this is just a little demo repository I made that doesn't actually have a remote yet. So to do that, I would use git rebase onto. So I want to make sure I explain this right. Git rebase f. I want to copy this SHA because this is the commit ID. I guess is what they call it, right? Because that should be, well, basically, but what I mean by SHA, just to be clear, that's what these are, right? These commit SHAs. But usually you don't need the whole thing. You just need the first 5 characters, but I'll just copy the whole thing for now. Why not? Since it's up there in the log. And this is how you would do it if you didn't have this fancy GUI that Git VS Code has. Okay. So git rebase to. So there is the commit I want to rebase onto, is right. Our latest one in main, create uppercase.py. And the parent is going to be this one. So I'm going to copy this one. Oops. Okay. Oh. What did I do? Okay. Let's try that again. I'll just copy them from here. And I want to make sure I have this right. Okay. Yeah. So I am on the right branch, correct? I should be on feature. I just want to double check. Excuse my typos. During time. Okay, yeah, we're almost done. That's fine. Yes. So git rebase onto, copy this ID, paste it. So we're taking the changes on this feature branch from this commit onwards. So basically we're not including create to uppercase, right? Because it's already in main. So we're saying we're taking from this commit onwards. So it's not going to include this exact one. It's going to look for ones that are ahead of this commit. And then we're going to apply it on top of main. So we can just write main there. Oh, I think I want to be. Sorry. I think I want to be on main. Oops. Damn. Okay. Oh, my typo created a new branch. That's something. But anyway, let me try that again. Oh, okay. Did I
I
mess
didn't know
that
the
up?
commit ID that you copied is the same ID as main. So right now you have committing the main onto main or something, if I understand the rebase.
Yeah.
Yeah, Noah, what I usually do here is I usually check out main like what you just did, and then I just do git rebase feature.
Maybe it's simple as that. Maybe I don't need to do the complicated onto that I usually do for our repo. So let's try that.
Yeah,
Thank
I
you,
don't
Pat.
normally go fishing for the individual commit IDs.
Okay.
You can either create a tag, which is sometimes an easier thing to remember, or the branch names. If you're grabbing a whole branch, you can just refer to the branch names. That's
If you
often
use the,
easier on the brain.
sorry, can I ask a question? If
Yeah.
you use like a specific commit ID, is that a way of like preserving the branch and not like rebasing the whole thing back onto main? Does that make sense?
Yeah. Well, the branch is preserved out of the way, but it would be a way of sort of being more precise about like what components of the branch.
Yeah, I
were
think you
rebased.
need you need to use the more complicated 3 parameter rebase onto to give it a range. If you just say go to this tag and rebase, it's that and everything after it. If you give it a range, you can like grab a couple of commits and not the whole everything
Right.
you've done.
Is it everything after the ID that you give, or is it everything between what you're rebasing onto and the ID that you're actually rebasing? I would think that the rebase would replay all of the changes from its head to itself, and then replay those on top of what you want to rebase onto.
Yeah, I think it's the latter of those. Yeah, what you said,
Yeah.
That'd be my guess.
And then anything that you had done after the ID that you rebased to remains not on what you rebased onto. So that's sort of a way of taking a subset of the list of changes and applying it.
Well,
And
Big
again,
help
this
with
is
brain-
one of the reasons why a lot of people choose merge, because you just merge a whole branch.
Well, we just rebased the whole branch.
You can
I mean,
you can do
you can
cherry
rebase
picking, which I've never
Yeah,
tried.
we try not to have huge piles of work that need to be rebased or merged, somewhat small development cycle, if possible, handful of files.
Right.
Yeah,
And usually,
I'm glad I don't work in corporate anymore when there are, thousands of files and dozens of workers all trying to get in on a particular release. It gets messy.
it gets messy. Someone had to do that pun today before we were done.
well, thanks everyone for tuning in. Hopefully it was helpful. It was more helpful than confusing of a discussion and demo for you. And
Thank you, Noah. This is
yeah,
great.
we'll see you all in 2 weeks.
Thanks.
Thank you
Goodbye.
very much.
Bye.